In this video, we're going to find the volume of a solid that is generated when the region between two curves is rotated about the x-axis. And one of the things about this type of question is that there is a misconception in here that could potentially lead to, well, let's face it, disaster, mathematical disaster. So I'm going to show you how this works and where to avoid the pitfall. So first thing I'm going to do is, which is always a good idea, I think, is to show the, kind of get a visual on what's going on here. Okay, so I'll draw the x-axis and the y-axis, and I'm just sketching here, so I'm not looking for something absolutely accurate here, but I've got y equals sine x, so I'll just draw, maybe half a cycle of that. And then I've also got cosine x, which is going to start like this. Okay, and in fact, where they intersect is at pi over 4. And the reason why we know this is because we obviously know the unit circle. And on the unit circle at pi over 4, both the x-coordinate and the y-coordinate are identical. And since we know the x and y coordinates are sine and cosine, that's exactly where they intersect. Okay, so here is pi over 4. And so the region that we speak of that we're revolving or rotating around the x-axis is this shaded region right here. Okay, so the easy way that we can do this is I can take I can basically just subtract volumes, right? So I could take the volume underneath the cos function from 0 to pi over 4, so that would be this area in here, revolve that around the x-axis, and then I can take the area here, the white area here underneath the sine function, revolve that around and get a volume there, and then just simply subtract the volume. So if I were to do that, the volume would then in fact be equal to pi times the integral from 0 to pi over 4, of the upper function here is sine x. Now it's going to be pi r squared, or pi f at x squared, so it should be not just sine x but sine squared x dx, minus pi times the integral from 0 to pi over 4 of cos squared x dx. Okay, so the problem here, though, is it's hard to determine the antiderivative of sine squared x. So what I can do is I can put this together and write pi. In this video, we're going to find the volume of a solid revolution that is generated when the region between two curves is revolved about the x-axis. So let's take a look at 11.7.3 here and start off with a visual, because the visual is always very helpful for us to decide what exactly is going on. Okay, so we're looking for the region between y equals sine x and y equals cos x from 0 to pi over 4. So here would be, let's say, one cycle, or I should say one half cycle of sine x, and in a different color, here is a half cycle of cos x. And we know from our study of the unit circle that where these two intersect for the first time is at pi over 4. Because if you recall in the unit circle at pi over 4, both the x and y coordinates are identical, which therefore means that the sine and cosine at pi over 4 are identical. Okay, so in fact the region that we speak of is this region in here, in between cos x and sine x. Now let's keep things straight here. This one here is cos x, and the other one is sine x. Okay, so we've already kind of had to recall some things that we learned in our previous math courses. Okay, so then the volume. Now maybe the easiest way to think about the volume is to say, okay, I'm going to take the volume from 0 to pi over 4 underneath the upper function cos x. So I'll figure out this piece here and revolve that around the x-axis. And then I'm going to take this area here underneath sine x and revolve that around the x-axis. And then I'll just subtract those two volumes. Right? And if you think that way, that's absolutely correct. We can do that. So I'll go v is equal to pi times the integral from 0 to pi over 4 of, now it's the upper function here, so that's cos x. Oh, but wait, it's supposed to be f at x squared, so it's cos squared x dx, minus the volume of this piece right here, which is underneath sine x. So again, pi times the integral from 0 to pi over 4 of sine squared x dx. Okay. Now, it turns out that it's actually kind of hard to determine what the antiderivative of just cos squared x is and just sine squared x. So I'm going to try to put these two together to make my life a little bit easier. Since they both have pi, I can factor that out. And since they both have an integral from 0 to pi over 4, I can kind of factor that out as well. And then I end up with cos squared x minus sine squared x dx. Okay. And so that actually is easier because, as you know from, again, previous math studies, cos squared x minus sine squared x is in fact, well, it's a number of different things, but we can write cos 2x dx. And that's a whole lot simpler to figure out the antiderivative of compared to what has come before. So I will just go pi cos 2x, okay, so that would be sine 2x as the antiderivative, because the derivative of sine is cosine, so we would get cos 2x, but then the chain rule would have us kick the 2 out, and there's no 2 here, so we're going to have to make sure that we have a half there to meet the 2 and cancel it out. Okay, and so that's it there, and so we end up with pi times half sine 2x from 0 to pi over 4 as our definite integral that we need to evaluate. Okay, so I'm just going to factor out the constants. Actually, I think I'll go right here. So this will be pi over 2 times sine 2 times pi over 4. Let's see if we could do it this way. 2 times pi over 4 minus sine 2 times 0 equals pi over 2 times, this really amounts to sine of pi over 2 minus sine of 0. And that gives me pi over 2 times, well, 1 minus 0, which is just pi over 2 units, cubic units. Okay. And just to end off, one of the most common mistakes is for students to not approach it this way and instead figure out the area between them first and then rotate the area. And that will not give you the same answer as if you were to rotate the volume and subtract the volumes. Okay, just a little hint.